plot x by m, extent of adsorption versus pressure. These three diagrams you have to see independently. These are three different graphs for at 273 Kelvin for the adsorption of a gas. As x by m increases, as pressure increases, x by m also increases, but there is no sharp increase here. 273 Kelvin, the increase is not that dominant. Here you can see at 244 Kelvin, means temperature has reduced from 273 to 244. These three diagrams you have to see independently. This, though it is drawn together, these are three different graphs. The extent of adsorption and pressure, as we increase the pressure, naturally on the surface when we increase the pressure, the gas molecules will come more and more closer. Adsorption will naturally increase. But as temperature, how it vary with the temperature, extent of adsorption, how it vary with temperature. At 273 Kelvin you can see the temperature is high, the amount of gas adsorbed is low. 244 Kelvin, as pressure increases, extent of adsorption increases. At 195 Kelvin, the temperature is lowest among these three. The extent of adsorption is more as the pressure increases. Means the physics option increases with the decrease in temperature. As you heat, the gas will escape. The tendency of gas to escape is more because the force of attraction between the adsorbent and adsorbate is van der Waals in nature. Hope it is clear to you. See it as a three different diagrams, though it is drawn together. Three different isotherms, constant temperature diagrams they are. Extent of adsorption versus pressure. The extent of adsorption increases with increase in pressure. So at 273 Kelvin, the adsorption is lowest, and 195 Kelvin, the adsorption is highest. It's clear to you? I hope so. Now we come to x by m to this for Chemy's option. He has given Freundlich adsorption isotherm, gave us a relationship. Extent of adsorption is equal to k into p raised to 1 by n. If I take logarithm, I have to write log x by m is equal to log k, log a into log b is equal to log a plus b, log k plus 1 by n log p. In the sense, this log a into b is equal to log a plus log b, log a raised to x is equal to x log a. These are logarithmic rules, you know. So it is log x by m is equal to log k plus 1 by n log p. This is the equation of a straight line. We can interpret it as the equation of a straight line. That is y is equal to mx plus c. Here what we have to say is, when we plot y versus x, we plot y versus x, we will having a line having slope m and intercept c. This you studied in maths. We plot y versus x, the slope will be m and intercept will be c. Corresponding to y we have log x by m, corresponding to x we have log p. So the slope will be 1 by n, intercept will be log k. This is slope. I have drawn it here. Log x by m versus log p will be a straight line, because as pressure increases, x by m automatically will increases. So it will be a straight line having intercept log c and slope 1 by n. Is it clear to you? So we say that Freundlich adsorption isotherm gave us a relationship for the extent of gas adsorbed and the pressure. Now from this equation, I am numbering it as 2, equation number 2. This is equation number 1. Consider the case 1. Always remember, this is adsorption of a gas on a solid. In this case 1, suppose 1 by n is 0. I am not telling n is 0, 1 by n is 0. So the whole term become 0. So that the equation can be written as log x by m is equal to log k plus 0. There is no meaning in writing 0. Means k is a constant. So x by m is a constant which is independent of pressure. Is it clear to you? When we write 1 by n is 0, x by m is a constant which is independent of pressure, because the pressure term has got no significance here. Clear to you? Case 2 if I write, see here, Case 2, if 1 by n is 1, that case, yeah, n is 1 if we write, if n is 1, log x by m is equal to log k plus log p, means x by m depend upon pressure. X by m is depending upon pressure. Is it clear to you? Freundlich adsorption isotherm, which deals with the first case, what I have taken is adsorption of gas on a solid. The extent of adsorption x by m, how it varies with the pressure, that relationship it is given, x by m is equal to k into p raised to 1 by n, or I can write it as x by m is proportional to p raised to 1 by n, means k is a constant, so equal sign if I replace with proportionality, it is p raised to 1 by n. Now I have taken logarithm, so it is log x by m is equal to log k plus 1 by n log p. As you know, it is y equal to y is equal to mx plus e. If I plot log x by m versus log p, it will be a straight line having slope 1 by n and intercept log c. In case of physics option, this is a particular absorption of a gas on a solid is being plotted at different temperatures. This is an independent diagram, this is another independent one, this is another independent one at constant temperature diagrams. So we call it as isotherms. This is also constant temperature diagram, temperature is constant, kept constant. Here we can see physics option decreases with increase in temperature, temperature increases down, physics option also decreases. So there are two cases we discussed. Case 1, 1 by n is 0. So 1 by n is 0 means the whole term is 0. So log x by m is a constant, means extent of adsorption is independent of pressure. In that case, it is a constant. If 1 by n, this case you see, if 1 by n is 1, x by m is proportional to p. Yeah, if 1 by n is 1, log x by m is equal to log k plus log p. This case, x by m is directly proportional to pressure. Yeah, x by m is depending on pressure in that case. This is first case. Suppose, now it is very easy for you to understand adsorption from solutions. Solution normally, adsorption taking place from solutions, normally we do not write the pressure term, we write the concentration term. The pressure term has to be replaced with the concentration. I will write C, that is concentration of the solution. This is concentration term. Instead of P, you need to write C raised to 1 by n. So x by m is equal to k into C raised to 1 by n. Log x by m is equal to log k plus 1 by n log C. So if I write here, this you have to see, if I plot log x by m versus log p, it will be a straight line having slope 1 by n and intercept log, where is the equation? See, log x by m versus log k having slope 1 by n and intercept log c. If we plot log x by m versus log c, not log p, log c, slope will be 1 by n and intercept will be log c. Same thing, only difference is instead of p, it is concentration. Same condition is applicable. If 1 by n is 0, log x by m is equal to log k. That case, extent of adsorption is independent of concentration. I cannot say pressure, it is independent of concentration because log c term become 0. Case 2 you see, if 1 by n is 1, log x by m is equal to log k plus log c, means extent of adsorption is depending upon the concentration of the solution. So clear to you? Freundlich adsorption isotherm, two cases we have discussed. One is adsorption of a gas on a solid, adsorption in solutions. In solutions, instead of pressure term, we have to use concentration term. Clear to you, I hope. Now we are starting with the term catalyst. You are familiar with the catalysis. Catalysts are substances added to a chemical reaction to increase the speed of chemical reaction. In catalysis, we are learning so many different terms. First, what we will be learning is what is catalysis or what is a catalyst, what are the various type of catalysis, what is the term promoter means and what the term catalytic poison means. The first term, catalyst, is, what is a catalyst? Catalyst is a substance which is added to a reaction system to speed up the reaction, to increase the product formation, or catalyst provide an alternate pathway. Catalysts provide an alternate pathway for the reactants to combine each other and produce product. It provides an alternate pathway or an energy low pathway for the products to form. So, catalysis follows adsorption procedure, or it adsorbs the reactants on the surface of the catalyst. More the surface area of the catalyst, more the effectiveness of the catalysis. For example, catalyst will not involve in any of the chemical reaction. If you take 5 milligram of a catalyst, at the end of the chemical reaction that 5 milligram will be left out. Means after the reaction it remain intact, it won't involve in any of the chemical reaction, but it provide an intermediate pathway for the chemical reaction to take place, an energy low pathway for the chemical reaction to take place. So, surface area is an important thing. The catalyst can be in contact with so many reactant molecule. So, the catalyst normally we powder and add in a reaction system to increase the surface area. Here the process of in catalysis, or we can, the most common reaction which you are familiar is N2 plus 3H2 gas, ammonia manufacture using iron catalyst is 2NH3 gas, means ammonia gas is formed. This is a catalyst which we are using. The most familiar example which you know is ammonia manufacture. In this case, nitrogen combined with hydrogen to form ammonia. Iron is used as catalyst. Iron, if we add molybdenum to the reaction system, the catalytic activity of iron increases like anything. In the sense, the molybdenum acts as a catalyst to iron. The substances which increases the catalytic activity of a catalyst, such substances are known as catalytic promoters. So, promoters, it is clear to you. Now it comes to, see, this promoters and poisons works like our friends. Suppose some friends, when they come to us, some people come to us, we have a positive vibration, we will be excited to work with them, we are comfortable with them. Such substances which help us to work properly or work effectively, such substances are promoters to catalyst. The substances which inhibits, for example, if the carbon monoxide gas is in the reaction system, the catalytic activity gets slowed down, or the catalyst get poisoned with such substances which reduces the catalytic activity of a catalyst is called catalytic poisons. Is it clear to you? Next come to the term type of catalysis. There are two types of catalyst. One is catalysis, I mean homogeneous catalysis and heterogeneous catalysis. Homogeneous catalysis, as the term itself indicates, the catalyst and the reactants are in the same phase. Phase in the sense, if catalyst and reactants, catalyst is a solid, reactant also should be a solid. The catalyst is a liquid, reactants also should be liquids. If it is gas, both should be gases. That case, you can see homogeneous catalysis. This is sulfuric acid manufacture, as you all know. SO2 plus O2 giving to SO3. The reactants are in gaseous phase and the catalyst NO, which is also in gaseous phase. Here this is very common example. Sucrose, yeah, cane sugar, C12H22O11. Hydrolysis of sucrose, as everybody knows, it will give you glucose and fructose. The catalyst which is used is sulfuric acid. This is also in liquid state. Water, of course, it is a liquid, and sulfuric acid also in liquid form we have taken. Clear to you? Now it comes to heterogeneous catalysis. In heterogeneous catalysis, the catalyst and the reactants are in different phase. Catalyst can be solid, reactants can be liquids or gases. So, heterogeneous catalysis, the most common example is this. The reactants are gases, but the catalyst is a solid. Second example, this you have studied in class 11. Oil, it has contain unsaturation. Any substance, unsaturated substance on hydrogenation, hydrogenation means addition of hydrogen, we use nickel, palladium, platinum as catalyst. Catalytic hydrogenation we say. Oil, of course it is a liquid form. Hydrogen, it is a gas, or oil can be taken in gaseous form also, or alkenes can be taken in gaseous form. And hydrogen, nickel catalyst, it produces ghee. Instead of writing that, I can even write like this, CH2 double bond CH2, this is alkene, react with hydrogen in presence of nickel. Suppose this is in gaseous form, hydrogen is of course a gas, you in presence of nickel which is a solid, you will get CH3 alkane. This is nothing else but catalytic hydrogenation. Reactants are in one phase, catalyst is in another phase. So it is called heterogeneous catalysis. Here this case, it is nothing else which is catalytic hydrogenation. You have studied in class 11th CH2 double bond CH2 which is an alkene. It is in gaseous phase. H2, it is in gaseous phase. Hydrogen addition across the double bond. The normal catalyst what we use is nickel, palladium or platinum, that is catalytic hydrogenation we say. The product form is an alkene, CH3. This case clearly you can see that is what it is written, oil which is containing unsaturation. On addition of hydrogen it gets saturated, oil become ghee. So this case it is catalytic hydrogenation, reactants are in one phase, catalyst is in different phase. The last content of today's topic which we are concluding the lesson with is the activity, the factors or important features of a catalyst or the important features of catalysis especially. First one is activity of a catalyst. Activity as a term itself means how effectively a catalyst can chemisorb the reactants. How effectively the catalyst can form bond with the reactants, that is called activity, or how effectively it can lead the reaction to give to large amount of products. Yield will be more. The activity of a catalyst means the capacity of a catalyst to activate a chemical reaction. See, as you have seen N2 plus 3H2, the catalyst of course is iron, which will give you, in Le Chatelier principle also we apply here, but the catalyst will give you considerable amount of product, means it is a very good catalyst, its activity is good. Next comes to selective